reviewed what A stands for, B stands for, C stands for, and D stands for. So with these 4 features, we're going, and knowing what the parent graph looks like, we are going to just start plotting. So first things first, this y equals function is not yet in this proper format because your parentheses need to lead with just an x. So whatever's there, in this case a 2, has to be factored out. Factored out means divided out. So here's a little bit of a tricky thing. What is 2 pi over 3 if I divide a 2 out of it? Aiden? Correct. 2 pi over 6, right? So dividing out a 2, if I take, I'm not going to normally show this work, but just for those of you who don't see that as well, if I divide out a 2, I'm essentially multiplying by a half, which is always just going to double the denominator, which then Aiden reduced in his head to pi over 3. Although actually on this one, because your numerator is a 2, you're just sort of pulling that 2 out. You can look at it that way too, but they won't all work that way. So this method I just showed is what you should do. So y equals that. So now we're going to graph a cycle of sine. So what we kind of need to know first and foremost is, where do I start this? So what if it normally starts at 0, 0, where is it now starting based on shifts that have happened? So before I get this underway, it says 1 period. So I'm just going to do mostly the first and the fourth quadrant. And normally my sine curve starts at 0, 0, goes up to 4, and down to negative, or goes up to 1 and down to negative 1, which will be up to 4 and down to negative 4 here. But where's my, I want to always have you give me 2 things. Where am I starting and where am I ending? So based on my, I'm not starting at 0, 0. Based on my phase shift, where am I starting? Andrew, pi over 3. So I'm starting shifted pi over 3 units to the right. So you can write at x equals pi over 3 if you want. And my 1 cycle, so there's my start set point. My 1 cycle is going to end a full period later. So we're going to add a period onto this, but how long is a period? It is normally a 2 pi, but this has been horizontally stretched or compressed, so that's going to change the period. You calculate the period by doing 2 pi over b, which is 2 pi over, what's our b value? What's our b value? Two. So 2 pi over 2 just gives us a period of pi. So what if it starts at pi over 3, what's pi units after that going to bring us to? What's pi over 3 if you add pi onto it? Pi over 3 plus pi. In order to add them, I need a common denominator, right? So multiply by 3, multiply by 3. So pi plus 3 pi is 4 pi over 3. So this is ending at 4 pi over 3. Now, because we essentially have 4 quadrants within each curve, however long this is, it makes sense, however many units you're going to put between these, it makes sense to kind of keep it nicely divisible into 4 parts, because 1/4 of the way from pi over 3 to 4 pi over 3, we want to reach a maximum, and then we want to reach a 0, and then we want to reach a minimum, and then we want to reach, back to your ending point. So figuring out what to scale your graph by and what to count by can be one of the hardest things to make this all work out. I'm going to say this. If your period, well, if you're starting at a pi over 3, and then you also want to split that into fourths, I think I just multiply. If you wanted to do it in thirds, but then each of those has to be split into fourths, I would split it into twelfths so that everything ends up on a vertical line. So I only have, though, I don't have like 12 pi over 12 available. So I'm going to do it this way. I'm going to do 1 pi over 12, 2 pi over 12, 3 pi over 12, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi over 12. So that'll be pi. 13, 14, 15, 16, 17. I don't think I'll get that high, but. So because I didn't have 12 squares, I went halfway through. So pi over 3 is essentially at 4 pi over 12. So that's where your cycle is going to start. 1, 2, 3, 4. And then your cycle is going to end at 16 pi over 12. I'm getting a common denominator. Pi over 12. And which means, so I did my start and my finish, which is on my midline of 0, right? Can we all agree? Plus 0, our midline is 0. So I just graphed my starting point and my ending point, and I like to start with that so I know where my whole picture is, and then I can keep everything symmetrical. So I'm going to have another 0 halfway in between those. So one's at 4 pi over 12, one's at 16 pi over 12. What's halfway between 4 and 16? 10 pi over 12. So there's another 0. And then what's halfway between 4 and 10? Because that's when I'm going to reach my maximum. And then halfway between 10 and 16 is going to be when I reach my minimum, right? So scaling it like this helps it like work out nicely so you're not guessing in the middle, and so you also know exactly where each of these 5 critical points is, because you're going to have to be able to say what the coordinates are of all of these points. But the only other thing we have to touch on is our altitude of 4. So positive 4 means we're going to hit our maximum first. What did I say? Halfway between 4 and 10 would be 7. And we want to go to an altitude of 4. So you also have to scale the y-axis, but that's much easier. And then halfway between 10 and 16 is 13. With an amplitude or a minimum of negative 4. So there is one of these curves. And they just said 1 period, so that's fine. So you may also be asked to list 5 critical points. Every curve has 5 critical points. So our starting point, we put it as 4 pi over 12 because we were counting by 12s, and that made it easier at the time. But I'll go back to being reduced. So pi over 3 comma 0. And then 5, 6, 7 pi over 12. That's where the getting that common denominator of 12 and knowing what to count by is helpful. Because finding 7 pi over 12 without that would have been tougher. So 7 pi over 12 comma 4. And then we're back to, is that 10? 10 pi over 12, which is 5 pi over 6. See, otherwise, if I didn't get that common denominator and count the way I counted, you guys would have had to have found the halfway point between pi over 3 and 5 pi over 6. I'm not sure how that would have gone because there's a different denominator on them. So you would have gotten a common denominator, and then you would have gone halfway between 5 pi over 6 and 2 pi over 6, which would have been 3.5 pi over 6, which is like a complex fraction. It's just kind of ugly. So I like to, based on my denominator of my starting point, and always that you're splitting things into fourths, I always like to count by whatever that becomes. Makes it all easier. 11, 12, 13 pi over 12. Negative 4 is the next point. And then 16 pi over 12, which just puts us back to 4 pi over 3. Are your 5 critical points. So the graphing that we do this year is just a little bit more complex because in Algebra 2, they're pretty good about, number one, they don't do phase shifts very often. They're very few and far between. When they've asked phase shift questions on the Algebra 2, it seems to be like in this format, and they just say, what is the phase shift? And you just have to know that's pi over 3. But actually having to do it in Algebra 2 is very few and far between. I don't know if I've ever seen it on an exam. And also on that, you have a calculator. So that's also an added bonus that you don't have here. Any questions? Okay. So on the next one, again, first things first, we have to get it in that format, which means we have to factor out a what? Mackenzie? 4. And so what's left in parentheses? Sarah, can you tell us? Yep. So that's that. So our cosine graph looks like this, right? So we want, where's this starting, where is this ending? So it's starting where? Olivia? Negative pi over 4. And it's going to end one full period later, but we have to calculate that. Our period is 2 pi over 4, because b is 4. So our period is pi over 2. So if you added pi over 2 onto this, how many units, where is that? Negative 1/4 pi plus 1/2 pi. Puts you where? Negative 1/4 pi plus 1/2 pi. Right? Positive pi over 4. Negative 1/4 plus 1/2. Puts you at positive 1/4. And so that's this point and that point. And they have an amplitude of what, since we have to start at a maximum? John? What's the amplitude? 1/2. So if I'm starting at negative 1/4 pi and ending at a positive 1/4 pi, and every period is cut into fourths, a denominator of, splitting that up into fourths when it already is in fourths, those already work with each other. So we don't really have to do much with that. Up here, this was counting by thirds, but our period was counting by fourths, so that's where we had to come up with the 12. This one is cut in fourths, and we always are counting in fourths when it comes to the 4 different sections of a curve. So I'm just going to keep it like that, but I'm actually not going to count by fourths because my graph would be over too quickly. I'm going to actually space, I'll count by fourths, but I'm going to space it out more evenly. So like I'm going to count, this will be my negative 1/4. Oh boy. No lead. It's not going to be I'm just spacing this out so I see more of my graph. So there's -1/4, which I went out 4 units to get to. So I'm going to go out 4 units to get there on this side. And then I'm starting again at a maximum, which will be at a 1/2, but I'm also going to spread it out here. Maybe I'll call this 1 so that my -1/4 pi and 1/2 is right there, and my +1/4 pi and 1/2 is right there. So I've graphed my starting point and my ending point. Now I'm going to go halfway in between those, which is at what x coordinate? 0. And go to my minimum, which is at 0, -1/2. And then halfway in between these two, because I counted out 4 units, I know that obviously the halfway point is 2 units out. And 2 units out there as well. And then I have my 1 cosine cycle. So my 5 critical points, -pi/4, 1/2. What about this one? -pi/8, good. Now, share with everyone how you did that, because I'm positive not everyone could get it that quickly. So he just he just split this difference, -pi/4, which is this amount of space, in half. -pi/4 divided by 2. Again, when you divide a fraction by 2, you simply double the denominator. Then we have 0, -1/2, and then +pi/8, 0, and then +pi/4, 1/2. Now, if you wanted to, going back to like the reason we counted by 12ths up here, this was cut into thirds and everything from there should be cut into fourths. You could take your starting value and just divide it by 4 and count by pi/16. I just would get a little nervous with that, because if this was any bigger of a number, it wouldn't fit. But that is essentially by spacing it out 4, which was kind of coincidental. I did kind of do -pi/16, 2pi/16, 3pi/16, 4pi/16. So that being 2pi/16 reduced to pi/8, and so on. Okay, because I do think scaling is the toughest part of all of this. Any questions? Do we have time for one more? Oh, we definitely have to do this one. Oh, I don't know. This one's got a midline. All right, we're going to do the midline one. The nice part about this midline one, oh, I should put my y-axis to the left, is there is no phase shift on it, because that -1 is at the end of the problem. So when you have a midline of -1, you kind of draw that in with a dotted line. I'm going to immediately regret this, but trial and error, you'll see, and you'd probably go back and change something. But this is your midline. We're starting at 0 because there's no phase shift. And we're going to end a period later at 2 pi over, what's our b value? 1. So we're going to end at 2 pi. And so if I want to take 0 to 2 pi and cut it into fourths, I maybe should count by pi/4, just to make my life easier. So 1 pi/4, 2 pi/4, 3 pi/4, 4 pi/4, 5, 6, 7, 8 pi over 4, which will be 2 pi. Now, again, my positive cosine looks like this. By the way, if you do a negative cosine, you guys know it's upside down, right? So you go minimum to minimum. This is still a positive 1/2, so it's a positive cosine. So I'm starting with an amplitude of a 1/2 above my midline. My midline is like my new x-axis. So this is what I said I was immediately going to regret, because a 1/2 of a unit of an amplitude above my y equals -1 line would be right there. So that's my starting point, and my ending point is over there at 2 pi. My halfway point is obviously at pi, which is a 1/2 a unit below the midline. And then halfway between my max and my min is a quote-unquote 0. It's not really a 0, obviously, because it's not hitting the x-axis there. But it's on the midline. And halfway there. So because I counted by ones on my y-axis, there's a very subtle, not stretched out cosine graph. Okay? Now this last one, just to kind of cut to the chase on it. If it's an absolute value function, y equals the absolute value of your trig function, the entire graph has to be what? Positive or 0. Okay? So you're going to graph this as you normally would, and I don't know exactly where it's going to be, but let's say it's going to look something like this, and it's going to go above and below the midline. Once you have the graph all scaled and all of that, and you're ignoring the absolute value signs at first, wherever your x-axis is, the absolute value, all it's going to do is it's going to take the bottom half of the graph and do what to it? Since it can't be negative, and it's going to take the absolute value of all these numbers, where is this section of the graph going to go? It's currently negative. It's going to become positive. So it's going to reflect over the x-axis and give you something that looks like that. Okie doke. So it might be half the graph that's below the x-axis. It might be just a fraction of the graph. But whatever parts are below the x-axis, just erase them and reflect them into the positives. Any questions? Only one.